Here you go. I'm in my little tiny cupboard. We're going to try and do a drawing on this microscopic little whiteboard. Let's see if it's something that you can see, and let's see if it is helpful. Okay, so what we're going to draw here is this is what's going on with the picornavirus. So you're going to have a genome, and at the front end of the genome, it has this structure that will draw like a little clover. And remember, this is the internal ribosome entry site. And then further along in the genome, there's going to be another important structure, and this is going to be called the cis-acting replication element, CRE. We will get to that in a little bit. And then if you get all the way down to the end, you will have a poly-A tail. Not forever, but for like 300 A's. So that's the genome. Those are the important structures that are on there, and they each have a different role to play. Cis-acting replication element is going to be where we make primers for the virus. Yeah, that's kind of neat. The IRES is going to be how we translate the virus, and the poly-A tail is also going to help out with the translation. Now here at the beginning of the virus, instead of a cap, we have that, remember that thing, and it's called VPG. So virus protein genome associated, just like so. Yeah. And there we go. VPG is going to be up there, looking great. And so what happens is, normally you have a ribosome, and the ribosome is going to have, let's see, factor. So it's a eukaryotic, which is a little e for eukaryote, initiation factor. So it's like capital I and capital F. EIF, and then different numbers. And so this is going to be 4E. Remember, 4E is going to bind an mRNA cap. And then we're going to have over here, 5, there we go, 4A. So 4A is going to be a helicase. And this is part of the ribosome. This is the normal way that messenger RNAs get translated. And then connecting these two, we're going to have a big thing, which is going to be called eukaryotic initiation factor 4G. 4G, awesome. And then associated with these, we'll have a 4B, and we'll have a 3. They're very instrumental in making the ribosome work, but they're not things that the picornavirus messes with, so I'm just putting the dotted lines around them, so we know they're there, but we don't need to do anything with them. Okay, and then we're going to have the main part of the ribosome, which we'll draw it a little bit more like it looks, which is going to be the 40S. And so 40S equals the small ribosome subunit. Yeah, small ribosome subunit. Awesome. And so normally, 4E is going to be bound to the cap structure. So CAP, there we go, a little cap. Ooh, that's tough to see. Let's switch to blue and see if we can see that a little better. CAP, bam. Yeah, I like it. Okay, and then messenger RNA. And somewhere along here, we're going to have our start codon, which is going to be AUG always. So an AUG equals start codon. And if you don't remember what a codon is, go look it up. Yeah, it's one of those units of 3 nucleotides that we read together. And so this start codon, AUG, is going to be the codon that always puts in methionine amino acids. That's the one that's going to bind to it. And so this is the only way that we start, which means that every protein in the world starts with a methionine. Yeah. So there you go. A fact that you probably, hopefully, already knew. Yeah. Okay, so that's the normal order of business. Now, what picornavirus does is it wants to cheat. So it wants to use the machine, but it wants to break it in a way that nobody else can use it. This is like going in and licking, something to claim it as yours. That's basically what the virus does. And that's why, once again, picornavirus is basically the worst. Yeah. So when picornavirus comes to town, it has a special protease. And the special protease for the poliovirus is going to be the protease called 2A. So we'll say this is the viral 2A protease. And all these things are proteins, or rather, factor 4E, 4G, 4A, 3, and 4B are all proteins. Yeah. The 40S ribosome is mostly made of RNA. It's a big piece of RNA that actually does translation for us, which is super cool. And so the viral 2A protease comes in here and it actually cuts right there. So it's going to cut 4G, which means that 4G is actually going to break down because it's cut in half. The two halves do not survive for long on their own. And which means that 4G is not going to be able to connect to 4E. And if 4E and 4G are not there, then 4A is not going to be happy. It's not going to say go. And that means 3 and 4B aren't going to work. And so the 40S ribosomal subunit is not going to work. Cutting off 4E destroys the ribosome. Unless you're a picornavirus. And in that case, forgot to get an eraser. So we're going to get an eraser next time. Let's just use the good old hand eraser. Why the heck not? So, let's wipe this out and wipe this out. So picornaviruses don't have a cap. They instead have that internal ribosome, IRES. And what it does is, so we've lost this and we've lost this. This simulates, so it's going to reach around, it's going to make a little structure that reaches around and it simulates 4G and 4E. So here's our IRES structure, boop, 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 right there. And so, that is the idea. And so because of that, we have now positioned the AUG, the start codon of the virus, at exactly the right spot. And we have both broken the ribosome so that the cell cannot translate anything anymore. And we have found a way around that so the virus can still be translated in abundance. And so what do you think this does to the cell? I'll show you in a slide, but it's pretty dramatic. Yeah. Cells are normally translating proteins all the time. Constantly, they don't have any other way to do business. And when you stop the cell from being able to translate, they can only stand this for about 15 minutes before they just die normally. And so the picornavirus actually stops the cell from translating, but bit by bit, it shuts down one ribosome at a time until it's killed them all off. And then the cell dutifully manufactures tons and tons of nice translated picornavirus and not a single other thing. That's how the picornavirus wins. So once the picornavirus gets in there, this cell is dead. It's going to be dead fast. It doesn't really want to fight back. Its best opportunity at this point is to die quickly and take the picornavirus with it. So that's where the dynamic is with picornaviruses. They are little beasts, absolutely. Okay, so that's the end of this one, and now we'll go back and talk through it with a diagram.